Okay, here we are going to the cube. I've deliberately set the current limit really low, like 5 mils. As you can see, we at least one time broke a million neutrons a second. One of the problems here is these bursts are so short, they're much sub a second, most of them. I've done this by running the gas pressure down to 1.6 times 10 to the minus 2 and then using the ion source to get it right on the edge. Something I've noticed here that I had not heard before is it got into a oscillation that sounded an awfully lot like 60 hertz, even though nothing in this system switches at that rate except the power supply of the vacuum pump. More later. Here it is doing that thing that sounds like 60 hertz. I've got it running kind of stable. It's only running at 30 kilovolts or so. I'm going to back off the ion source. And went out. And back to this stuff. Very hard to adjust this right. I'm thinking that since we have power gain between the two grids, we can make this oscillate at a rate determined by the transit time of the particles between the two, giving us essentially DC negative feedback, but AC positive. I'm going to play around with that a little bit at any rate. Well, it turns out that by changing the current limit when it's in this motorboating mode, I can tune it, or I could. You know how things misbehave in front of the camera, right? Yeah, it's slow. Run the current limit up a little bit the next time it happens. About an octave higher at 8 mils than it was at 5 mils current limit. Interesting, eh? And we just broke a million neutrons a second again with only 8 milliamps as a limit, but most of the time we're doing about 300-400 microamps here. By the way, I think that hissing sound I'm hearing, which is below the threshold of counting, is probably the fact that we're already oscillating at some RF frequency, and I'm going to have to get a working scope going to ascertain that. And see, it just quit, and I didn't do a thing. It was just hovering on the edge of all kinds of instabilities.